Well, good morning, everybody. Thanks for choosing to come and listen to the Alumasc Green Roofing CPD seminar. My name's Tony Doyle. I'm a Northern Business Development Manager for Alumasc Roofing. I've got a colleague in the room with me, Phil Graham. He's one of our area sales managers. He's just informed me that the last time he was in a lecture theatre, he was hungover. He doesn't remember being in the lecture theatre. Not hungover. So, we're going to be talking about green roofing today and blue roofing. So we've got a bit of an agenda here. We'll start off just defining what is a green roof, the design considerations of waterproofing and the components of the green roof itself. Then we'll talk a little bit about why you might want to use a green roof. Then we've got an introduction to blue roofing, which, if you're not familiar with it, is all about storm water attenuation at roof level. And we've got a couple of case studies, and then we'll be done. So, if I just give you a brief introduction to the Alumasc Group, first of all. It's a FTSE listed company, turns over something around about £100 million a year last year. These are some of the companies that are part of the group. Hopefully, some or all of them might be familiar with you. We've got the rainwater systems, that's usually one that people know quite well. Facade systems is external renders and insulations. We've got Roof Pro, which is plant support systems, Harmer drainage outlets, Gatic at the bottom there is pavement drains, slop drains, access covers, that kind of thing. Levelux is a solar shading company, and Blackdown, indicated at the bottom left there, that's our green roof division. They grow all their own product down in Somerset. So I work for the roofing systems division, which is part of exterior building products, and you'll see there we've got, along with the roofing systems, we've got the facade systems, rainwater systems, fascias and soffits, and the drainage system. So really we're looking at the complete external envelope of the building there, which can be offered in one package from us as one supplier. And within the roofing division we've got a variety of waterproofing systems. We offer green roofs, roofing accessories, which would be plant support, access ladders, gantry ladders, that kind of thing, roof edge guarding, the stormwater management, which we'll talk about later. So they're all part of the roofing systems division. So that really is Alumasc. So just starting off, what is a green roof? They come in various forms. We've got one on the left there is purely recreational green roofing. This middle one is a green belt area where the building has been camouflaged. And on the right we've got a exhibition centre up in Glasgow, which some of you may know. And the green roof there is purely an aesthetic feature on the building. What's a green roof? Hope there's no design and build contractors in the room. They sometimes get a bit offended when we show them this type of thing, but we're showing really the differential between what the concept of the green roof and the architect or the designer's idea might have been, and how, when it ends up with a design and build contractor, it can get value engineered, to be polite. Really we're trying to point out with this seminar what are the features that shouldn't be value engineered, and why those components are there, why it's important to retain them all within a defined specification. So if we go back to basics, what's a green roof? These are the basic components, which we will talk about in a bit more detail in the coming slides. We start off at the bottom with a waterproofing system of some description. There'll be some insulation contained within the system somewhere. But as for the green roof, there'll be a drainage layer, a growing medium of some description, and then some vegetation, again, which could be anything from rolled out seed and matting to quite intensive horticultural landscapes. We'll start off with the waterproofing. We as Alumasc offer several different waterproofing systems. We would, for flat roofing, we'd propose two really for work under green roofs. The go-to system really would be the hot melt system, which is a bitumen highly modified with rubber. It's laid a bit like liquid coating, but it's laid hot, so we'll roll out 3mm thickness of the hot modified bitumen. There's a reinforcement layer put into it, and then another 3mm layer on top, and then a protection layer. Ours is called Hydrotech. It's been around since the late 1960s. We're not aware of any failures of it yet. It's a pretty robust system, and that would be the one that we would generally offer for new build green roofing. The BBA certificate defines it as being there for the life of the building in terms of durability, so that's a pretty good recommendation. One of its advantages is that being so highly modified with rubbers, if it is punctured, it will self-seal. So you can see, picture at the top right there is an old-fashioned tyre gauge measuring the depth of the membrane. That's for quality control purposes before we bury it, so that we know that it's all been laid to the right thickness. But that little puncture hole will seal itself up anyway. Alternative system would be traditional warm roofing with bitumen felts. So we're showing here the insulation sandwich between a vapour control layer and the waterproofing layers. Critical thing here is that waterproofing layers must be root proof and tested to be root proof. There is a defined test. It's a German test where they line a box with the waterproofing material, put some soil in it and some very aggressive plants, and see if they grow through the membrane over a period of time. That's the defined test. So you're always looking, if you are specifying waterproofing for green roofing, make sure it is actually proven to be anti-root. So the green roof itself. First thing we'll talk about is the drainage layer. We're showing it here on an inverted roof, so we've got the waterproofing down at the concrete slab level. We've got an insulation layer, which would be an extruded polystyrene, but this could be on a warm roof just the same. The purpose of the drainage layer is, well, the clue's in the name. It's to drain water, rainwater, through the system and let it drain away. It's quite important that water isn't stored in the system, because it can get saturated, and if you don't have a drainage layer, or you don't have an adequate and suitable drainage layer for the green roof, this is the sort of thing that you can end up with. This is a roof that didn't have a drainage layer, and it's quite simply become saturated. There's nothing you can do for that roof now but remove it and start again. So the drainage layer is quite important. It will be the thickness and the type of the drainage layer will be defined by the type of covering that you're going to put on it. So they come in different thicknesses and different types, as we'll see shortly. Just to put some definitions in place, we talk about extensive and intensive green roofing. Just if we start on the left there with extensive, this is the simplest, usually the most economical method of doing a green roof. It's quite thin, so the growing medium layer, the hatched area there below the green, is typically 60, 70, 90 millimetres thick maybe. There's a drainage layer under it, and then we've got the waterproofing layer. The green area would probably be just rolled out sedum matting. It's the most common one, and we're talking about a typical weight of 90 kilograms, 100 kilograms a square metre. So that's the sort of lower economical end of the green roof business, if you like. The other end on the right is the intensive green roof. So this is where the imagination can fly, really. There'll be a design, a horticultural design, a landscaping design, which will include vegetation. It might include trees, shrubs, water features, lighting, paving, patios, all sorts of things. The depth of the growing medium there will vary according to what you're trying to achieve horticulturally. So it could easily be 500-600 millimetres thick, and we're up at weights then of half a tonne per square metre. But it could be anything. If we want to plant trees up there, it could be a metre deep. So obviously the roof has to be designed to take this into account at the beginning. So in between we've got semi-intensive areas, which really are degrees of depth and complexity of vegetation, somewhere between the extensive and the intensive roof. So we've talked about growing medium. First thing to say is it isn't soil, and the contractor can't take his waste excavations from the site and pile it up on the roof and call it a green roof. It won't work. The growing medium is a mix. It's a designed and engineered mix of crushed brick, light ag and bits of organic material, and it will be designed and engineered not just to a depth but to a grading of coarseness and quantities of fines. So it's there to provide air and water and nutrients to the vegetation, but it'll be designed according to the vegetation that you're trying to achieve. If it's too porous, water will run away. If it's too rich, you could end up with weeds and things that you don't want growing in there. And if it's too thin, it just may not suit the vegetation. It's a little bit of a complex table, but what we're just trying to indicate really is between extensive and intensive growing mediums there are different mixes. They'll be graded differently by grain size. There'll be different quantities of organic matter in there. They'll have different water permeabilities, so they are designed to suit the vegetation that you're trying to put on the roof. That's one that didn't succeed very well, one that we found, not one of ours, I would say. And this is what you will get if you don't have the growing medium of the right depth and composition. What we can see there, the red plants are indicating dieback, where the sedums are dying off, and you can also see the straight lines, the laps, where there's, rather than the rolls of the sedum matting having knitted together, they've shrunk back. So the roof is in a serious state of failure. So a little bit more detail. There's our extensive green roof. So we've got the top part, the brown part, typically say 80, 90, 100 millimeters thick of growing medium, sedum matting on top, drainage layer. One of the beauties of the drainage layer, what they do is like egg cups. They will hold water in those little cups, which is indicated by the blue bits there. When those cups are full, they overflow and the water drains away through the drainage layers. But in times of drought, when there's not much water around, at least there's some water left in the system there to help to moisturise the system. The green roof, by the way, doesn't always have to be green. Depending on the vegetation you're using, you can introduce all sorts of colours. So the sedums are a hardy, drought-resistant plant. They'll survive in coarse, thin substrates, possibly with low nutrients. They will come in different forms. So the most common form is in rolled-up matting, a bit like garden turf, but a bit more complex. Or they could come in plug plants, which could be planted on the growing medium on the roof, or even just come as seeds, and you could seed the roof. But obviously, you're looking at a much longer lead-in time till you've got your green roof at that point. This would be a semi-intensive roof, so now we can see, rather than just a thin layer of sedums, we've got a much more wider variety of horticulture going on, different wildflower plants. This would be more like a wildflower meadow. It will have a deeper layer of growing medium on it, possibly a deeper layer of the drainage layer as well. And if we get to intensive green roofs, this is the River Quarter in Sunderland, luxury apartments. So the areas that you can see, all the green areas and the paved areas, they're all green roofing. They're laid over a hot melt system for waterproofing, but some of those green areas, you can see they've got paving, water features, lighting stanchions, all sorts of things there. So we're talking about quite a deep build-up of growing medium on there, which, as I said earlier, could be easily 500 millimeters thick. If we look at the drainage layer on the graphic on the right there, you can see it's filled with crushed gravel. That's because of the weight of the system, of the green roofing system, could potentially crush the drainage layer, because they're only made of a thin polypropylene plastic. So that would be filled with crushed brick or gravel just to reinforce it and support it, but obviously it's still a porous layer. Not all plant species will survive on every green roof in every location. Different plants suit different locations, different geography, different areas of the country. You might not plant the same things down on the south coast as you would up in the north of Scotland. What we're looking at there is plants to the left and the right. The green ones, they're okay. Ones at the back are showing signs of a bit of distress. They don't look very happy. They're starting to die off a bit, and the ones at the front have died off. So it's an indication that sometimes the plants that get planted don't suit the conditions that have been planted in, or maybe it was a generic growing medium that didn't suit all of the plants. This is where the advice of the horticulturalists is useful of a particular roof to see what they think is going to be suitable in particular locations. In terms of design guidance, the Grow Guide is pretty much the Bible of green roofing. It's readily available. It's got a lot of good advice on green roofing from the waterproofing up. There's things like NHBC. They offer their advice. This is a bit of a complex slide with a lot of text on, but basically what it's saying is that they recommend that the full system, waterproofing and green roofing, comes from one manufacturer, because that avoids any arguments later on about bits of failure. So if you've got the waterproofing from one place and a drainage layer from another place and a growing medium from somebody else and vegetation, and insulation from another place, it's a recipe for disaster. If something goes wrong, then everybody blames everybody else. So the recommendation is to get it all from one place, and ideally that it all be installed by a single contractor who's trained in the application of the systems. So we're just going to move on to reasons why you might use a green roof or need to use a green roof. I'll talk about the things on the screen there: regulatory compliance, carbon capture, ecological reasons, creating amenity spaces, and stormwater management. Regulatory compliance is a little bit of a misnomer. There's no rules anywhere that tell you that you must use a green roof, but there are various bits of legislation, guidance, which encourage and guide people to using green roofing. Probably all starts back with Kyoto Agreement 2002, when countries got together to try and limit their carbon emissions. More recently updated in Paris, I think, and I think I've heard this week that China is now joining the carbon limitation international club, if you like, but the Americans are dropping out. So that's a moving picture. But one of the government's early responses was upgrading thermal regulations to try and control carbon emissions. But following on from that, we've got things like London Plan for Building, which positively encourages sustainable building, and in particular on roofing, green roofing. BREEAM is a useful encouragement. Green roofing can give you points for BREEAM in terms of floods, flood mitigation, ecological factors, enhancing ecology, that kind of thing. We'll talk about that in a bit more detail shortly. So carbon capture. I think most people will be familiar with the heat island effect, where buildings in cities can actually increase the ambient temperatures of the atmosphere around about. This slide here, the thermographic image on the right, gives a good guide on that. The blue areas are the cooler areas where the roof has had green roofing put on it. You can see the orange and the red bits are quite warm by comparison. So the green roof areas do cool the local temperature. They do that through solar reflection, through evaporation, and it keeps the local area a couple of degrees cooler. A live example of that was at Canary Wharf, where they did a retrofit green roof. Not on the tall tower, it's on the lower roofs, by the way. And this quote here from this gentleman at the Canary Wharf Company tells us that they've estimated that they save about 11.5 tonnes of carbon dioxide a year through reduction in heating and cooling, mainly in being able to turn down the air conditioning, was where they've saved most of it. And they estimate that saved them up to £5,000 a year in electricity costs. So that's all about cooling of the local atmosphere. I think it's generally accepted that trees absorb carbon dioxide. The data on it is a little bit vague and woolly because there's so many different tree species local climates, soil types and things like that. But it's generally reckoned that available data suggests that typical trees would absorb between 0.5 and 5 kilograms of carbon per year. There's similar vague data on green roofing for the same sorts of reasons and for the reasons that you've got different bedding, but the available data does suggest that about 50 square metres of sedum roof, healthy sedum roof, would absorb as much carbon as a healthy broadleaf tree. So a little bit vague, but just to try and put it in some sort of broad context. As an alternative to green roofing, more recently we have introduced a bitumen mineral felt with an olivine mineral instead. Now, olivine is a natural mineral. It's mined close to the Earth's surface. It's in huge quantities. I read recently it actually occurs on the Moon, it's on Mars, and it's in asteroids that have come from space, so it's obviously massively available. It has this capacity when it's mixed with the rainwater, or when rainwater falls on it. There's a chemical reaction, and it converts carbon. It takes carbon dioxide out of the rainwater and converts it to sand, magnesium carbonate and water, which are all dissipated away harmlessly. So this is a permanent reaction. It's a chemical reaction. The carbon dioxide is taken out of the atmosphere and completely neutralised. So what we've done is replace the traditional slate mineral on bitumen felts with this olivine mineral for that purpose. And moving back to our tree, the olivine is capable of removing, over its 30-year life, the tests indicate that it will remove 1.75 kilograms of carbon dioxide. If we do some arithmetic, we can work out that approximately 200 square metres of an olivine roof should be equivalent to our broadleaf tree in terms of carbon capture. So it's just to try and put it into a bit of a context. And we have a number of local authorities who are now specifying that to tick an environmental box, basically. Ecological things, we move on to brown and biodiverse roofs, all under the category of green roofing. The intention of a biodiverse roof is to, if you build something new, to replicate the footprint of the building up at roof level. So you've built on some virgin ground, you've taken that piece of ground away, let's try and put the benefits of that ground back up at roof level. So the biodiverse roof, we'll put our growing medium out there to some depth, depending on what we're trying to achieve. We'll leave it rough, mounded. We'll put some brick bats in it and some stones and some bits of log and things like that, and seed it and let it take place naturally to see how it grows. So it's not intended to be a landscaped, manicured landscape. It's trying to let nature take its course a bit better. So with the assistance of birds and insects and wind and the seeding, you end up with something like, hopefully, what you started with. Similar but slightly different brown roof. We've done the same sort of thing again here. So we've got our growing medium to some depth. We've got both the logs and the bricks and the stones and things. Leave it rough, and you walk away and leave it, and you see what happens to it. And basically, you leave it to the birds and the insects and the wind to let nature take its course. And over time, something will happen. You might be looking at 12 or 18 months, but you will get a natural habitat on that roof, which has just let nature take its course. So obviously, if you're doing that kind of thing, you might have to manage your clients' expectations, because if they see just a load of rubble on the roof and growing medium at day one, they might be inclined to hold some money back off you. Amenity spaces are a fairly obvious sort of thing, simply creating recreational space. These are all roof areas, even the ones on the right that look like external patios, they're all roof areas, landscaped in different ways, as you can see. The apartments on the left there on the side of the River Thames, so they've got their green roof areas just for recreation, and of course you can see the hot tubs in the middle there. So I don't think I could even afford the hot tub, never mind the apartment. That's another one, intensive green roof area. in my amenity spaces, as I said earlier, the River Quarter at Sunderland, luxury apartments, all amenity space for the use of the residents. So we move on then to stormwater management. We're all familiar with problems and risks of flooding. We have to work under the Flood, Water and Management Act 2010, trying to alleviate flooding, which indicates various measures that you should take with new building to make sure that you're not going to surcharge local drainage systems. So a green roof, depending on its depth and its type, will store a certain amount of rainwater within it. We've got some ideas there: water retention between extensive and intensive roofs and depths, but we can get anything from 40 to maybe up to 90% retention of stormwater within a green roof, and that's one of the drivers for using it. One problem with that though is that once the growing medium or the green roof is fully saturated, we've got to 100% runoff then, so you're no longer providing any stormwater attenuation. So one way around that is to use a blue roof. So a blue roof is an area where you're going to store rainwater up at roof level. So normal ways or common ways of attenuating rainwater off a building might be to put tanks in the ground, store the water down there, harvest it down there until such time as the rain stops and you can pump it out, but then you may have to pump it out, so you've got electricity costs and maintenance costs. We have a system whereby we can store rainwater up at roof level and just let it drain away slowly. So what happens is the two key components in this particular system. One would be the void former, which you see under the green area there, which doesn't have to be a green roof, it could be a paved area, a podium. But that's a void former, which might be, say, anything up to 200 millimetres deep. That creates a reservoir where we can hold water back. The second component, if you look down the bottom right, is the outlet. The roof would have a traditional flat roof outlet, but we have an insert that goes into it. The insert will vary in diameter from 10 to 25 millimetres, and what it is, it's a restrictor, so it's slowing down the flow of rainwater from the roof to the local drainage system. So we'd start off with the design figure. We'd know, or want to know, how much water can you drain off that roof, what's the flow rate that you're allowed to drain, and working back from that we design a restrictor, numbers of outlets and a size of void former. That's the restrictor there. So it's a normal outlet, but the red part and the grey funnel part is the restrictor, which slows down the flow of rainwater. We won't go into the calculation in too much depth. I don't want to put everybody to sleep on the first session, but basically what we're showing here is an example of a roof. So the criteria were, it's a job in London, it's 284 square metres. We would work to summer storm rain intensity, which are more intense than winter storms, shorter duration but more intense, but allowing for a duration of 6 hours, a climate change factor of 30%, so there's a lot of margin in there for safety. And at the end of the design we end up with storing a rainfall water depth within the void formers of only 109 millimetres, which would drain out over approximately 27 hours. So there's a flow rate figure there which is acceptable to the local systems. So all we're doing is just holding the water back on the roof, just allowing it to release slowly into the local system. And each scheme would be designed to suit a particular building in the local area. Cross section there's the restrictor outlet within an inverted roof build up, the void former and some paving over the top of it. There's another example there within a warm roof build up. Principle's exactly the same. Hold the water back and just let it drain away slowly. As a precaution, it's a fairly regular and obvious question. What happens if the restrictor blocks up, because these are quite small outlets and they do need to be maintained? We would always specify in a secondary outlet alongside the restricted outlet. It's piped into the same pipework, but it has an overflow pipe. So it's the one on the right there. The overflow pipe will be set to a certain height. So if our restrictor outlets have failed, the water builds up. Before it gets to a critical level, it would overflow into the secondary outlet. And just as a precaution, we can always put overflow weirs in parapet walls as a third level of defence, if you like. Regarding the weights of water on the roof, people often say, well, it's quite heavy. Well, water can be fairly heavy, and we can see there at 150 millimetres, it's what, 1.47 kilonewtons per square metre in loading. That's not a huge load on a flat roof. It needs to be designed in, but if we consider that very often on a new flat roof we'll have a concrete screed, which can be anything up to 5 kilonewtons per square metre, we will be leaving the screed out of these situations because we're working at 0 falls, so we don't need the concrete screed to provide falls. So part of the calculation will offset the weight of the screed for the weight of the water. So not saying the roof doesn't need to be designed specifically for the loading, it does, but there are mitigating factors when you use the blue roof to store your water. This is just the guidance, the building, the design code on the left there is about drainage, it's about maintenance. We talk about hydrostatic pressure. The pressure of water, even at 150 millimetres deep on the roof, is nowhere near the capacity of the waterproofing systems to absorb that. The Hydrotech, particularly in the bitumen felt systems, they have more than enough capacity to withstand the hydrostatic pressure that that stored water would impose on them. Quite important, before you bury a roof with green roofing or podium or anything like that, is to do leak detection tests. We would always insist on the waterproofing system being tested at day one when it's laid, but critically tested before it's buried, because particularly on new builds you can have a long period of maybe weeks or months between the waterproofing system being laid and the green roofing or the covering being put down, during which time a number of other trades have walked around it and battered it to death. So it's important to test it before the roof is buried, and as part of the guarantee system we would ask for those test certificates from a test house to put on file and verify that the roof is waterproof. Very briefly on CDM, really the implication for the green roofing is regarding future maintenance. People will need to go up there at the very least to clear outlets, and depending on the type of green roof they will be up there to do maintenance, horticultural maintenance, irrigation possibly. So you need to keep them safe and make sure they can't fall off the roof or through any voids. So it's necessary to design in some sort of mechanisms to keep people safe on the roof. Edge guard railing is probably the safest, most secure and easily used method, but it's quite common to put landline systems on the roof, or cable line systems rather, which people hook onto. There's no defined answer, but it's something that does need to be considered in the design of a green roof, is how are you going to maintain it safely in the future. A couple of case studies. This one's the Scottish Exhibition Centre in Glasgow. Some people may be familiar with the building. Norman Foster Architects. The green band that you can see around the bottom doesn't look a lot, but it's actually 6,000 square metres of green roof. And as you can see in the pictures on the right, some of it was at quite steep angles of about 55 degrees. So that was a bit of an engineering challenge in terms of how do you keep the green roof on the slopes and stop it sliding off. First part of the solution was to put those lugs in that you can see in the pictures on the top right, to retain the system, and then the growing medium was provided in geotextile tubes, or socks as they were called, which is those black tubes that you can see in the middle picture. So they're inserted on the roof and they're supported by the lugs, and then the plants were all plug plants individually inserted into the geotextile socks. So somebody would go along with a knife, star cut the geotextile, put the plant in. There was 36,000 plants put on there, and I believe the guy in the bottom right there is smiling because he's just put in the 36,000th plant into the system. Greenwich University, these are green roof areas. You see quite a detailed design there of planting, water features, trees, lighting, paving. It's actually the architecture department at Greenwich University, and I believe they do use some of the areas for trials and experiment of designs, but it's all amenity space. And this Bristol University is about blue roofing. So the building's in the bottom middle picture there. Waterproofing system was a bituminous felt system. I think it was our Derbigum system. The criteria here was, it's not immediately apparent in the picture, but the building is fairly landlocked. The proposed building is surrounded by, well, it's in a courtyard surrounded by other buildings. It's in the centre of Bristol. It's built on rock. The logistics of actually excavating water attenuation tanks in the rock and getting the spoil out of the centre through the tight streets made it almost impossible, but there was a planning SUDS requirement that they couldn't drain this roof into the local drainage system. So Fielden, Clegg, Bradley and Bath were the architects. They found our blue roof system and specified it for the roof. So picture on the top right there is the outlet, the normal outlet. The middle picture shows the restrictor within the outlet and the void formers, and the lower picture shows two outlets. The one on the left is the restrictor and the one on the right is the normal overflow outlet, which I was describing earlier. And then a green roof was put over the top of it. So that's a scheme which almost certainly would not have proceeded because of the SUDS requirement had they been trying to put attenuation tanks in the ground. The fact that they could attenuate the water at roof level made it economically viable to carry on. So that basically is it. Hopefully we've got some learning outcomes here. Hopefully you've learned something that you didn't know before you came in, and if you have, then I'll treat that as a result. If there is any questions, I'm happy to try and answer them for you.
Can it be walked on? Because there's some slides there with lots of roof lights but no specific footway.
Depends what you put down, and it is something that you would probably put into your design. If you're doing a landscape design, then yeah, we mentioned maintenance, people need to be able to walk, so you might put dedicated walkways down. If it's just pure sedum roof, it's not for regular traffic. So light maintenance, if you just occasionally walk across it just for routine maintenance, it will be okay, but you wouldn't traffic it. But obviously if you've got more sophisticated horticultural planting, then you're not going to walk on them because they're basically flower beds.
Yeah.
We often put green roofing in association with solar panels, for example, and they need certain maintenance as well. So you'd put defined walkways to get to the panels. And just a point of interest, which I didn't mention earlier, but if you are putting solar panels on a roof, they do work better around green roofing, because the panels always work better when they're cooler, and the ambient temperature round about will be cooler around a green roof than it would on a traditional waterproof roof. Okay, well thank you for coming, and have a good day.
Thank you.
Cheers, thank you.
Just to release your one. We don't want to have save.
No, it doesn't need to save.
Okay, just.